What's up, guys? Beautiful day here in Toronto, Canada. Oh, don't you guys love the summertime rain? Anyways, we're back here with our first call. We have another hotel suite unit that's giving us problems, so we're gonna go inside, take a look, see if we can wait out this rain. All right, as you can see, unit set to 65 degrees, cooling's on, fans running. Our indicator light is fine and solid, but our outdoor unit's not coming on, so let's see what kind of code we're generating here. We're gonna locate our cancel button, press it once, press and hold, aim at our system. Beautiful. There we go. We're on to our error codes now, so we're gonna cycle cancel one at a time. U4, nope. And we're back with an L5. That long beep, guys, is our lockout code. And then if you keep going through, you can see your other ones. But L5's our issue. We waited out the rain. It's actually turning out to be a pretty nice day here. So first things first, let's pop this top panel. And we can access our electrical section. We'll also take off our piping cover as well. Let's go. And our main power connection here. Careful when you guys do this, by the way. This is all hot behind here. So there's our main power in. All right, we'll do some basic first checks here. We'll check our inlet power here, which is our terminals on the bottom here. So we're looking for 200 volts, 208. We got 199. We know we have power coming in. No problems there. We'll check to ground per leg, 115, which is good. And our other leg, 115, is good. 1 and 2 is our power to our indoor unit. We'll verify that. We shouldn't have any issues there. 199, perfect. 1 to ground, 115. 2 to ground, 115. So our power's good. Next thing, what I'll usually do is I'll take a quick visual of the board, look for any obvious signs of burn marks, which I don't see. Now our power is still on, so we're gonna shut our power off and just make sure all these connections here, all these harnesses are on there, nice and tight in the way they should be. Looks like our board has a heartbeat, so that's probably a good sign. And we'll keep troubleshooting from here. What I've done now is I've taken all the screws out. These little systems here are freaking great until they break down. No room to work on these. So you got to take all these screws out. And we're trying to get out our compressor. So I've disconnected it off the board. By the way, I've checked all our connection points. They're good. These are insulated to hell. So we're going to pull all of this back. And we're gonna see if we can pop off this cover plate here. I tried jamming my leads in there. Not really sure if I'm getting the best reading because of how narrow it is. So we're gonna check right at our compressor terminal here. Let's check our compressor. We just pulled our cap off. So there's 3 wires coming into this compressor here. They're red, blue, and yellow. We're gonna go across each terminal on resistance. We have 1.1 ohms. 1.1 ohms and 1.1 ohms. So this compressor here is ohming out perfectly fine. Let's go on to our next step. All right, guys, let's check our condenser fan motor. We're coming off terminal S71 here. Now, I had to cut the leads after the harness. I'll join them afterwards because I don't have micro leads with me right now. They would go in here, and you can see my leads stand no chance of fitting inside those terminals. So if you guys are going to work on mini splits, I strongly suggest you invest in some micro leads for troubleshooting. But let's carry on with this. So keep in mind, we have 5 wires for our condenser fan motor. Remember this, blue on this particular Daikin system is always our common. So we're going to start with blue to white, and the reading we should be getting is 1 mega ohm or more. We have open windings, out of limits. So that's not a good sign. Blue to orange. Let's get a good read here. We have 62.8 kilo ohms. That's not good. We're looking for 100 kilo ohms or more on our blue to orange terminal. Next, we can check our blue to brown. which we have 56.94 kilo ohms. We're looking for 100 kilo ohms or more, or 100 ohms or more. I apologize. So this is no good. And then finally, our blue to red terminal here. We have out of limits, open windings. We're looking for 100 kilo ohms or more. So we know this condenser fan motor is dead. And our final check here is going to be our EEV, or electronic expansion valve. It's coming off of the S20 terminal down here. I had to do the same thing again, just cut it on the other side of the harness, and I'll reconnect these later. But with your EEV, here's our leads. We have 5 wires here. 1, 2, 3, 4, 5. Red is our common this time. So everything we're going to reference off our red lead. So every wire between our red terminal should be roughly between 40 and 50 ohms. That's how we're going to verify that our EEV is okay. 46, it's good. Let me separate these a little bit better. 46 ohms, and then finally our orange, 45.9 ohms. So we know our electronic expansion valve is fine. Now we'll check the board. All right, we have to turn the power on to check our control signal is what we're going to look for now, which will verify if our board is good or not. So let's turn that power on. And in the beginning of this video, I actually checked our 1 to 2, which is our power into our unit. We're looking for 208 volts. And we can check those one more time just so I can show you guys. So 1 to 2. 197, 1 to 3, 195. So we have proper voltage here, which is great. Now what we're going to do is we're going to switch our meter from AC to DC volts. And what we're going to look for is we're looking for pulsing voltages between terminals 2 and 3. These are our DC voltage here, 2 and 3. Control signal between our outdoor unit and our VAP. So we're going to put these leads on, and what we should see is a pulsing range. So your voltage will start from 0 to 9 volts, then you'll go into, teen volts, so 10 to 19, and then you're going to go up to double digits like 20s and then 30s. And keep in mind, you should never have a voltage above 45 volts DC. And you see my meter is going to pulse like crazy. And the only reason that says negative is because I have my terminals or my leads backwards, but here we go. So watch this. You see that? 26, 29, 30, 17, 39, 23. You see how it's all over the place? We're going to be looking for a pulsing voltage starting at 0 to 9, then from 10 to 19, then from 20 to 29, 30 to 40, so forth and so on. But remember, never above 45 volts. And we're nowhere consistent here. We are all over the place. 39, 26, 23, 32, 17. So this board is not putting a proper signal out, guys. This board is also finished off. That condenser fan motor took this board out, and yeah, we're gonna have to change our main board and our condenser fan motor. We verified that our electronic expansion valve is fine and our compressor. We'll go talk to the customer now and see what they say. All right, guys, so customer said no problem. Let's get her fixed, but we're waiting on our distributor to locate the parts. So now we're on to our next call. We got a lunch room, locker room, storage room, no air conditioning. I think customer said it was 25 degrees there, set for 22. Let's go take a look. All right, what do we have here? This is our thermostat. Yep, we're set to 21, it's 24 and a half inside temperature. If you're wondering why this controller is in this electrical room closet, it's because it has zone sensors throughout the change room and locker room space. All the rooftops here used to be off of these Johnson controllers here. I think they only have one now, which is what, HVAC 2 or 1 front office, but we're not dealing with this. This has no problems, and this one's been decommissioned. So we're looking at this here. Let's go out to the rooftop and we'll take a peek. Unit 3. All right, rooftop 3. I believe this is his second feature on my channel. First impressions, yeah, that's not good. Our inducer motor is running with a call for cooling. So just from experience, I'm gonna assume that the rollout's open, maybe the high limit. let's open this up and see what we find. All right, let's open up this electrical panel door, see what our board's saying. Okay. All right. As you can see up here, we have an error code on our board, that flashing red light. Let's count the beeps or the flashes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 flashes. What does that mean? Come over to our handy dandy schematic here, or our error code chart, and as you can see, 9 flashes. Ignition control locked out. Ignition control failure. Let's take a deeper dive into this. Here's our burner door. Our inducer motor is behind here. It's running, and it shouldn't be because it's been hot as hell. I don't see any reason why the heat should be on or even trying to run right now. So I immediately see a manual reset rollout switch. So when that switch is open or tripped, this motor will run 24/7. So we're gonna try this first. Yep, and wouldn't you know it, I just felt that click down. But let's go back to our main panel, see if our code has eliminated itself, which it has not. So we're gonna check for our high limit next. So I just reset this rollout. You can actually physically feel it click in. It's just a thermal disc that will pick up if the flames come back out, and this will open up. It's a safety procedure, but with your meter, this is how you're gonna check. You're gonna go across the rollout switch. So either terminal here, either side, we should have 0 volts if it's closed, which we do, but I would double check if I was you and go from one side to ground. So we have one lead here, kind of scratched away any of the rust, and let's get our ground here from our inducer housing. We have nothing. I check your other side, and we have no voltage. So we know that our limit switch, which is before this rollout in series, probably has an issue. Okay, we located our limit switch. It's right here, and it looks awful. Extremely rusty. Can you guys see that? Right there. Both these wires are just a 24 volt through the safety, but let's get a reading with our meter, see if we even can, because these are in awful shape. So we'll go on one side of our pin here to ground. We have 23, 26 volts there. Let's try our other side. We have nothing there. What we're gonna do though is we're gonna pull these spades off and check through our spade connections, because I don't trust that limit switch. So we'll shut the power off and we'll ohm out this safety next, and then we'll jump it out just to verify that inducer motor shuts off. Our power's off now. Let's see if we can get this limit switch out. That's in awful shape. That is in awful shape. And this is what it'll look like. Okay, there's our problem right there, guys. So the actual thermal disc on the other side of this, I'll see if I can pull it out and show you, has snapped clean off. I haven't seen one of these snap off in a while. Look at this here. We got to be careful because this has to come out and we'll have to order a new one. There it is. There's the other half of our high limit. So there it is there. So what has happened now is that these have become so corroded that they've just snapped right off. And I'll show you now how to ohm one of these out if it was still in, full contact. We can still ohm it through these little arms. Let's do that. All right, so here's what's left of that limit switch anyways, but these arms here, they just carry the voltage through our main part of our limit switch, which is right there, going into these terminals and therefore making our heating safety circuit. So if I was to put a lead here on resistance or continuity and here, you can see that our thermal disc itself is still good. It's just our connection point is cooked. So we're gonna need a new one of these. We'll check the rollout as well now. All right, let's check our rollout switch now. Power's off. We're just gonna pull our leads off either side. Meter's still in continuity, ohms, resistance. We're just gonna go across and we are good. We have continuity through our rollout switch, which is great. And finally, before we go pick up this limit switch, let's cut that off. We're gonna jump out this limit switch and make sure our inducer motor stays off. You never know, right? Could have a faulty board, a faulty relay as well, keeping that inducer motor on 24/7. By the way, guys, that's a safety in this unit. So a safety procedure that they will all take is if this limit switch ever did fail, that inducer motor will run 24/7 to get rid of any heat that could be built up inside of the machine. So now that we have our nice jumper on, we'll be careful that it doesn't short to anything and blow our control fuse on our board. We'll turn the power on and make sure this inducer motor stops. Let's fire up the power. Boom. There's a 5-minute control waiting ASCD on these Yorks, which I've told you guys about. That's a 2-flash control waiting. Real pain in the ass on these. So if you're ever wondering when you restore power why you have 2 flashes on your board, that's why. But as you can see here, our motor is not running anymore. That high limit is exactly why our air conditioning wasn't running. Because keep in mind that heating safety will supersede any other control points in this unit. So if we have an issue with the high limit, that inducer will run 24/7, not letting the cooling come on. Let's go see if we can source out a limit and we'll replace it, check our air conditioning. All right, we're back with our brand new limit. That's what it should look like as opposed to what it was. Anyways, we're gonna install this now. So keep in mind that this thermal disc here always faces down, not up, but down. So we're gonna slide this guy into his little home here. Go home ball. And we're gonna use new self tappers here because our old ones were rusty as heck. So there's one. And we'll put our second one in. And I've crimped on new connectors here, so they just go on 1 and 2. Boom, boom. And this fell off. This is just our ignition lead. We'll put that back too. All right, let's start the power up and check back in with you guys when the AC kicks on. Oh, and by the way, guys, forgot to mention before, if you ever come across any sort of limits for heating equipment, whether it be a primary high limit, a secondary, rollout, it doesn't matter, a flow switch or a boiler, you can jump these out for testing purposes only like I did before, but never leave sight with these jumped out. You can cause a world of problems. So that's just a little tech tip there, guys. Never, ever leave heating safeties jumped out. Okay, guys, our cooling just kicked on. Our inducer motor is now off because we've replaced that high limit switch. We're running off a 410A refrigerant here, which is our pink scale, like I always say. Anyways, we're running at about, what, 140 PSI, which is a 48 degree evaporator. Head pressure's 315, 100 degree coil temperature. These pressures look awesome. Let's hook up second stage and we should be good here. And here's our second stage compressor pressures. 300 head, close to 100 degree condenser, and we got 125 suction pressure low side, about 42 degree evaporator. Both compressors are running awesome. We'll quickly check the condenser fans and we'll be out of here. All right, condenser fan 1, 2, 3, and 4 are all operating. I think this service call is all taken care of. On to the next. And our final call of the day, well, I wouldn't really say it's a service call. We need to size up a new rooftop install. So what that means is we're gonna be measuring the curb and the adapter if it has one, checking voltage, and I'll show you guys how to do that now. Here's our rooftop here. Let's go. First thing we're gonna do is we're gonna get the length of our rooftop. So we're gonna hook it onto this brown flashing here, because that's our original roof curb. We'll try and find a good spot to make sure our tape stays in place so we can pull it tight. Come on, baby. Nice. and we're gonna drag it the length of the rooftop. So it looks like we're right around the 7-foot mark here. So there's our 7-foot marker right there. Now that's a little bit extra because this kind of tapers down, but we know that our length of our unit, because it's a box or a rectangle, is 7 feet. So that's gonna be our first measurement for our new rooftop replacement. Next, we're gonna measure the width of this rooftop. So we're gonna do the same thing, except on the shorter side. So get your tape in a good spot. And where do we end up? We're at about 56 inches. Right there, 56 on our tape to the end of our flashing. So what I like to do sometimes is I will upsize my measurement by about 1 inch, so 1/2 inch on each side, just to make sure that when this new rooftop comes, we're not gonna have any issues with this not fitting. I've been on jobs before where the rooftop was ever so slightly too small. You have to start undoing these hoisting points to open up this bracket, and it's just an absolute nightmare. So when you guys do measure in future, keep in mind, always upsize your measurements a little bit, because you don't want to be the guy, you know, come the day of the job to have a rooftop not fit and start having to cut it, you know, mess around with all the railings, brackets. Just upsize your measurements a little bit, play it safe. All right, so the next thing you guys are gonna wanna look for is your rating plate on your machine. This unit here is a carrier. This is your model number, serial number, gives you motor specs. Most importantly here though, you're gonna wanna find this here, your power supply. So we know our unit is 575, 3-phase, 60 hertz. That's very important. You don't wanna have the wrong voltage unit come crane day. And the final thing I'm looking for on this rooftop here is our economizer. So what this does is, when our ambient temperature is below 65 degrees, give or take, there's a damper inside here that will open, shutting off our compressors and therefore saving hydro for our customer. It just essentially provides free cooling. But if you guys are ever in doubt, if you have an economizer or not, they're always gonna be on your return side, so your filter door. Just pop that door open, and usually, you can see right there, it's stamped economizer, but you'll have a board in here. The newer ones will actually have a, depending on the brand, but like a Jade controller, so it could be digital. They all have actuators. That was here once upon a time. This unit's very, very old, so this wouldn't apply to most of the newer stuff we have, but there we go. It looks like somebody's forced this one open, I guess to get some free cooling. I don't know if it's gonna do them any good when it's, you know, 40 degrees Celsius. Anyways, check for an economizer, because that's something you're gonna wanna include with your rooftop pricing. I believe units that are above 5 ton usually will come with one built in anyways, but just something else to keep in mind. Oh, and by the way, you guys are also gonna need your crane dimensions. So your up, which is your building height, and your in. As you can see here, we are several hundred feet to the edge of the roof all around. This is dead center of the building. So I'm gonna have to measure that now, but keep that in mind, guys. This building's approximately 30 feet up, and I'm gonna guess about 200 feet in. So we'll need one heck of a big crane. And to end things off here, guys, I'm gonna show you the curb adapter now. This is a different unit, but you see this right here? That fits on our original roof curb and adapts to our rooftop size. So be careful. You guys might have to measure both of these if you're replacing a new rooftop and it has a curb adapter. Take both measurements to be safe. One at the bottom here, where that fit on our existing roof built-in flashing, and then our adapter size here, because you never know, you might be able to get a unit that will fit this curb adapter. Maybe you'll have to change both. And yeah, I hope you guys learned something today. If you did and you enjoyed this content, please like, subscribe, and comment, and I'm gonna check you guys in the next one. Take care.